And this is our final Tier 3 Lesson 7 Sum and Difference of Cubes. So from before, we have our sum and difference of perfect cubes. So this set will be same, opposite, always positive. So, and then remember the form's the same, AB, A squared, AB, B squared. So, I need to figure out how I can write this as a sum or difference of cubes. Well, this is a difference. I need the cube root of each. Well, the cube root of x cubed is just x. And the cube root of y to the sixth is going to be y squared. And let me show you why real quick. So if we had y squared times y squared times y squared, right? That's what cubed means. Then we would have 2 plus 2 plus 2 for y to the sixth. Okay, we can do the same thing with this term. So we have the cube root of each. So the cube root of 64 is 4. And then z to the ninth is going to be z to the third. All of this to the third. Cubed or to the third, same thing, right? Same sort of situation. Z cubed times z cubed times z cubed is z to the ninth, right? Z, 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 9 z's. And then I just put it in my form. So I'm using this one. So I have a, which is xy squared, minus b, which is 4z cubed. That was this term. A squared is going to have xy squared squared plus, right, opposite sign, ab, so xy squared 4z cubed. And then always positive sign, b squared. So 4z cubed squared. Now there's a little bit of simplification I got to do. So this term is fine. I'm going to leave it alone. xy squared minus 4z cubed. Then this term, I need to square this. X squared is just x squared. Y squared squared, this is that power to a power rule from earlier. So this is y to the fourth, right? If you just think of y squared times y squared is y to the fourth. Then these, there's no like terms, so I'm just going to reorder it. I'm going to put my number first and then just go x, y, z. So plus 4x y squared z cubed. And then cleaning up this term, 4 squared is 4 times 4, so 16. And z cubed squared is going to become z to the sixth. Okay, z cubed squared, well then that would be those two. So there's 6. All right, and then I have another example for you where I want to do my difference of perfect cubes, but it's not a perfect cube yet. What I want to do is I want to factor a -2 out of both terms first. So I'm going to bring -2 outside. -2 divided by -2 is 1, and we're just left with x cubed. -250 divided by -2 is now positive 125. Now that I've factored out the GCF, this is a perfect cubed, right? X cubed, and this is a perfect cubed, 5 cubed. So now I can use my form for a sum of perfect cubes to factor it into this. So we could say that this is -2 times, we have AB, so x, same sign, plus 5. Then a squared, x squared. Opposite sign, so minus AB, so 5 times x, right? 5 times x. And then always positive, plus 5 times 5, 25. And then I should go on. I should try to factor my quadratic equation. So I could use the quadratic formula. So I'm not going to write it again because you've written it enough. So negative b is now negative 5, so 5 plus or minus b squared, so 5 squared, 25, minus 4 times a, which is 1, times c, which is 25, all over 2a, so 2 times 1. Well, 4 times 25 is 100, and 25 minus 100 is negative 75. Now I'm going to simplify my negative 75 over here, right? Pull out my negative 1, give me I, and break down 75. I don't know how that is, so I'm going to use long division. And it's 15. And this breaks into 5 and 3. Here's my pair. This is a leftover, so I get 5 square roots of 3i. Hopefully you're that good at these at this moment. Okay, and then we'll plug it back in. So 5 plus or minus my simplified root over 2. And when I split this fraction up, nothing's going to happen, so I'm just going to leave my answer the way that it is right now. Okay, so there's my completely factored polynomial. I had this root, and then my other root, this x plus 5. I could set it equal to 0, and that's going to give me negative 5. So there's my 3 answers.